We'll start with this example 5. An RCC pile of 18 meter overall length is driven into a deep stratum of soft clay having an unconfined compressive strength of 3.5 ton per meter square. The diameter of pile is 30 centimeter. We have to determine the safe load that can be carried by the pile with a factor of safety is equal to 3, right? Now this is our driven pile, right? So at the tip of pile we will be having QB, and at the interface of this pile we will be getting this QF. Now Q ultimate is given, not Q ultimate, this is unconfined compressive strength is given 3.5 ton per meter square. So simply we can find out this undrained cohesion, that is equal to QU by 2. So we will be getting 1.75 ton per meter square. Now we are having this depth of pile as 30 centimeter, right? So this D is 0.3 meter and L is equal to 18 meter is given. Factor of safety is given 3. Okay, now this this C is equal to Q by 2 we know. So by the static formula, QU will be equal to QF plus QB. QF will be equal to small qf into AF, small qb into AB. So we will be getting, and NC is equal to 9 as per Scampton. QB will be given by C into NC, and NC is equal to 9. This is 9 into CU, and this QF will be equal to alpha into C, and alpha is the adhesion factor, that is taken as 0.95. In case of soft clay we are using this, alpha is equal to 0.95 into C, and AB will be equal to pi by 4 D square, and AF will be equal to pi into D into L, right? So we'll be putting all the relevant values in this particular expression, and we'll be getting this ultimate load as 29.3 ton. Now the safe load will be given by ultimate load divided by factor of safety. We'll be getting this safe load as 9.76 ton. Now this is another problem, example 6, that says 200 mm diameter, 8 meter long piles are used as a foundation for a column in a uniform deposit of medium clay. Unconfined compressive strength is given 100 kN per meter square. Adhesion factor is equal to 9. There are 9 piles arranged in a square pattern of 3 by 3 for a group efficiency of 1. Find the spacing between the piles. We have to neglect the bearing action. Now the data provided is QU is equal to 100 kN per meter square. So simply we can compute this undrained cohesion. C is equal to QU by 2, and that will be equal to 50 kN per meter square. Alpha is given 0.9. Alpha is equal to 0.9 is given adhesion factor for an individual pile, right? Now neglecting the bearing, individual pile capacity. Now we are not taking this point bearing into account. We are only considering the skin friction effect, right? Just because we have to, somewhere they say that we have to neglect the bearing. So ultimate load for the individual action will be computed like this: alpha CU into AF. Alpha is given 0.9, CU is given as 50, and pi into D into L. So we'll be putting all the value in this particular expression, and we'll be getting ultimate load as 226.19 kilonewton. Now for 9 piles, QUG will be equal to N into QU. So we'll be getting N is 9 and QU is 226.19. So the group ultimate bearing capacity will be given as 2035.71 kilonewton. Now when we are considering as a block, right? So we'll be neglecting this skin friction, and not neglecting skin friction, we'll be neglecting the bearing and QUG. Just because, why we are neglecting bearing? Because it is given in question, we have to neglect the bearing for individual action and group action. So QUG will be equal to alpha CU into 4B into L. So alpha is 0.9, CU alpha is equal to 0.9. Given what they have given. Okay, no problem. So now they are considering this alpha is equal to 0.9. Generally, if alpha is not given, we are considering as 1, but in this case they have assumed this as 0.9 into CU into 4 into B into L. Now this will be treated as a block. Now this won't be like 4 into, this won't be pi into D into L. This is 4 times B into L is the length of pile group. So 4 into B will be equal to 2 times the spacing plus diameter into 8. Now from second and third, right, for group efficiency is equal to 1, that will be equal to QUG individual is equal to QG block. So QUG individual and QUG block, when we are equating these two, we will be simply getting this spacing. So spacing comes around 0.6 meter. Now B is equal to 2S plus D. So the width of pile group will be equal to your 1.4 meter, coming less than 3 meter. Now we have to design a pile group to carry a 400 kilonewton in clay with an unconfined compressive strength of 60 kN per meter square. Adhesion factor may be taken as 0.6. The pile are of size 300 mm and 6 meter long. Assuming factor of safety is equal to 2.5. So the data provided, QU is equal to 60 kN per meter square. We will be simplifying this underend cohesion, that will be equal to unconfined compressive strength divided by 2. We will be getting underend cohesion as 30 kN per meter square. Now the load to be carried will be equal to the safe load multiplied by the factor of safety, that is 400 into 2.5, will be getting this 1000 kilonewton. So the number of pile will be equal to the load that the pile has to take divided by the single pile load capacity. So the single pile load capacity can be found out using this formula. QU is equal to CU into NC into AB plus alpha CU into AF. So on putting all the relevant values in this particular expression, we will be getting ultimate load as 120.87 kilonewton. Now the number of piles will be calculated like this: 1000 divided by 120.87, coming around 8.27. So we cannot have a pile like 8.27. So what we will be doing, we will be taking nearby its value, like 9 piles will be taking, right? And when we are using 9 pile, obviously the load carrying capacity of pile will also increase. QUG will be equal to CUNC B square plus alpha CU into 4B into 6. This is for the pile group. So 1000 we are using, and in this case we are finding out this B. B comes around 1.008 meter, right? So when the ultimate load capacity in group is equal to 1000 that we are using, so width coming around 1.008 meter, right? So what we will be doing, we'll find out the spacing corresponds to this 1.008. So we'll be getting this spacing as 0.354 meter. And we know this minimum is, and we know this, that minimum spacing must be equal to 3 times the diameter. So it will be like 3 into diameter will be 0.9 meter. So this much number of piles, 9 piles having diameter or not diameter, basically the width of pile group will be equal to 1.008 meter, and the spacing of the piles and group will be 0.354 meter, right? But we have to provide this minimum spacing as 0.9 meter. Now moving on to the example 8, 9 piles of 300 mm diameter and 8 meter length are arranged in a square pattern for the foundation of a column in a uniform deposit of medium stiff clay. Unconfined compressive strength is provided 100 kN per meter square. Now the center to center spacing of pile is also given 900 mm. Adhesion factor is also given 0.9. We have to compute the capacity of pile group. We have to assume the factor of safety is equal to 2.5. Now everything is shown in a schematic diagram like this. Now diameter of pile is also given 0.3 meter, length of pile given 8 meter, adhesion factor given. Now we can compute this underend cohesion as unconfined compressive strength divided by 2, 50 kilonewton per meter square. Ultimate load of pile group can be simply computed if we take the individual pile load capacity considering, so N into QU. N is like 9 piles are arranged in a square pattern, and then QU is CNC AB plus alpha C into AF. C into NC, NC is 9 and AB is the bearing area, plus alpha C is 0.9, then C into pi into D into L, right? So the group efficiency, so the group capacity, the ultimate load capacity comes to be 339.9 kilonewton. Now the ultimate load of pile group, considering this as a group or a block, so QG will be equal to QU into AB plus QF into AF. So QU will be equal to C into NC into B square, not D square. Not a D square means pi by 4 into D square, because in this case we cannot use this pi by 4 into D square just because this is a block case. So B square, 0.9 into 50 into 4 into B into L. So the group ultimate load will becomes around 5008.5 kilonewton. From first and second we have to take the lower value. So lower value is 333.9 kilonewton and divided by the factor of safety to obtain the safer load. So safer load is 1335.9 kilonewton. Now moving on to the example 9, a raft foundation is supported by a pile group consisting of 15 piles arranged in a 3 row. The diameter and length of each pile are 300 mm and 15 meter respectively. The spacing between the piles is 1.2 meter. The foundation soil consists of a soft clay layer having cohesion is equal to 3.2 ton per meter square and gamma is equal to 1.9 ton per meter cube. We have to determine the capacity of pile group. Now the data is given, like cohesion is given 3.2 ton per meter square, gamma is given 1.9 ton per meter cube. Now first we will be considering the individual action of piles. So the skin friction can be computed like alpha into C. So alpha C is 0.9 into 3.2. We are assuming this alpha is 0.9, so it will be like 2.88 ton per meter square. C is equal to 3.2 is given here. Now AF can be computed easily with this formula, pi into d into L. So pi into diameter is given 0.3, length is given 15. So we will be having AF as 14.14 meter square. QB can also be computed like this, CNC. CNC means C into NC is 9 as per Scampton. Then 9 into C is your 3.2, so 28.8 ton per meter square. AB can also be computed like this, 4 by pi by 4 into d square. We will be getting AB as 0.071 meter square. Now the individual capacity of each pile can be computed using this formula. QU is equal to QF plus QB. QF will be equal to small qf into AF plus small qb into AB. So you will be getting QU as 42.75 ton, right? Now the group capacity as per the individual action, it will be N into QU. Number of piles are 15. QU is 42.75. So we will be getting individual by individual point we will be getting this group capacity as 641.37 ton. Now the considering the group action of pile, now when we are considering the group action of piles, we will be computing this length. So 1.2 into 4 plus 300, right? So this is one, we will be taking in the length direction, sorry, in the width direction and in length direction. So in length direction, this will be your spacing and 4 times your spacing plus this diameter 0.30. Now in this case we are having 5 spacing, so 5 into S and this 0.30 as diameter. So you will be getting B this much and L this much. Now what we will be doing, considering the group action, this QB into B into L plus 2B into 2L into DF into AC minus gamma DF into BL. On putting all the things in this expression, we will be getting QGS 678.05 ton, and that is greater than 641.37 ton. So we will be taking lesser of these two, right, and we will be dividing it by factor of safety to obtain the safe bearing capacity, that is 256 ton. Now moving on to this example problem 10, it says a raft foundation has to be supported by a group of concrete piles. The gross load to be carried by the pile group is 250 ton including of height of the pile cap. The subsoil consists of a 25 meter thick stratum of normally consolidated clay having unconfined compressive strength of 4.8 ton per meter square and on the effective unit weight of 0.9 ton per meter cube. We have to design the pile group with a factor of safety of 3 against shear failure. Now this is your ultimate load, this is your pile cap, and these are freestanding piles, right, and this is the length of pile. Now arranged in a square pattern. Now let use 16 number of 400 mm diameter reinforced cement concrete piles in a square formation. Now let the spacing is S. We are assuming this spacing as equal to 3 times the diameter. So spacing will be 3 times of diameter, means 3 into 0.4, that will be 1.2 meter. Now length is now L is the length of each pile. Undrained cohesion can be computed using this formula, QU by 2. So it comes like 2.4 ton per meter square. We are assuming this alpha is 0.90. So small qf, small qb, AF and AB can also be computed like this. QF is equal to C into alpha. So we will be getting 2.16 ton per meter square. QB is equal to C and C. So it will be C into 9. We will be getting 21.6 ton per meter square. AF as pi BL. So we will be getting this 1.257 L meter square. Then AB as pi by 4 D square. So we will be having 0.126 meter square. Now the capacity of each pile can be computed using this formula. We will be having QU in terms of L, 2.715 L plus 2.722. Now the safe bearing capacity of each pile can be computed using this formula, QU by 3 means factor of safety. So we will be getting this expression as QS. Now the actual load carried by pile will be the whatever safe bearing in terms of pressure we are getting divided by the number of piles in group. We will be having actual load carried by each pile is 15.625. What we will be doing, we will be equating this with this one to get this length of the pile group. So the length of pile group is 16.50 meter. Now what we will be doing, we will be checking for the group action. So considering the shear failure of block of dimension B into L into D, so B is equal to L, and that is 3S plus D. So 3 into spacing is 1.2 and D is 0.4. So you'll be getting width as 4 meter. Diameter is equal to, not diameter, B into D. D is 16.5 meter. That is 16.5 meter here, right? Now the capacity of pile group can be computed using this formula, right? And we'll be getting Qg is equal to 894.24 ton, and the safe bearing capacity of pile group can be found out using this formula, that is divided by the factor of safety. So we'll be getting safe as 298 ton, that is greater than 250 ton. So hence the design group of pile is safe from the consideration of block failure. So the safe coming more, the load that is coming is 250 ton, so obviously it will be on a safer side. So likewise we can do all these numerical based on pile foundation. So you can have a look over these numericals. Example 1, example 12, right? So in my next class I will be discussing about this efficiency of pile group.